Aujourd'hui, on va apprendre, espérons-le, à utiliser le langage R avec Swirl. Donc normalement, je dois faire ça. A priori, ça marche. Peut-être que je devrais les redoire. So when you see answer, the R prompt, or when you are asked to select from a list, that means it's your turn to enter a response. Then press enter to continue. Select 1, 2, or 3 and press enter. Donc, proceed. You can exit Swirl and return to the R prompt at any time by pressing the escape key. If you are already at the prompt, type by to exit and save your progress. When you exit properly, you'll see a short message letting you know you've done so. When you are at the R prompt, typing skip allows you to skip. Typing play lets you experiment with R on your own, so will ignore what you do until you tap next, which will regain Swirl's attention. Typing back and Swirl to exit, your progress will be saved. Typing main returns you to main menu, and info displays the option again. Ok, ça fait beaucoup à retenir. Skip, play, next. Play next, ils vont ensemble. By, main, info. Okay. To begin, you must install a course. I can install a course for you from the internet, or I can send you to a web page which will provide courses, options and directions for installing courses yourself. If you're not connected to internet, type 0 to exit. So R programming, the basics of R, regression models, the basics of regression modeling in R, statistical inference, the basics of statistical inference in R, exploratory data analysis, the basics of exploring data in R. And don't install anything for me, I do it myself. On va faire le 1. Course installed successfully. Please choose a course or type 0 to exit Swirl. Donc, R Programming, c'est le course que j'ai installé. Ou Take me to the Swirl course repository. Donc ça, c'est tous les cours que j'ai installés. Please choose a lesson or type 0 to return to the course menu. Basic building blocks. Workspace, etc. etc. On va faire le 1. In this lesson, we'll explore some basic building blocks of the R programming language. If at any point you'd like more information on a particular topic related to R, you can type help let's start at the prompt, which will open a menu of resources, either within RStudio or your default web browser, depending on your setup. Alternatively, a simple web search often yields the answer you're looking for. Okay. In its simplest form, R can be used as an interactive calculator. Type 5 plus 7, press enter. Ça c'est pas de syntaxe particulière ni rien. Okay, you're really on a roll. R simply prints the result of 12 by default. However, R is a programming language, and often the reason we use a programming language as opposed to a calculator is to automate some process or avoid unnecessary repetition. In this case, we may want to use our result from above in a second calculation. Instead of retyping 5 plus 7 every time we need it, we can just create a new variable that stores the result. The way you assign a value to a variable in R is by using the assignment operator, which is a less than symbol followed by the minus sign. It looks like this, nice and flush. Think of the assignment operator as an arrow. You're assigning the value of the right side of the arrow to the variable name on the left side of the arrow. Par exemple, A plus petit que 5 plus 7, maintenant A ça sera 12. To assign the result of 5 plus 7 to a new variable called x, you type x flash 5 plus 7. This can be read as x gets 5 plus 7. Give it a try now. You got it. You'll notice that R did not print the result of 12 this time. When you use the assignment operator, R assumes that you don't want to see the result immediately, rather that you intend to use the result for something else later on. To view the contents of the variable x, just type x and press enter. Try it now. X, 12. Now, store the result of x minus 3 in a new variable called y. What is the value of y? Now let's create a small collection of numbers called a vector. Any object that contains data is called a data structure, or numeric vectors are the simplest type of data structure in R. In fact, even a single number is considered a vector of length 1. The easiest way to create a vector is with the C function, which stands for concatenate or combine. To create a vector containing numbers 1.19 and 3.14, type C 1.19. Try it now and store the results in a variable called Z. Donc Z concatenate 1.1 9 et 3.14. C'est bon ça? Ok, faut s'habituer parce que les virgules sont des points et les points virgules sont des virgules, donc ça à l'anglaise, comme Excel en anglais. Anytime you have questions about a particular function, you can access our built-in help files via the interrogation command. For example, if you want more information on a C function, type point d'interrogation C without the parentheses that normally follow function name. Give it a try. This is a generic function which combines its arguments. The default method combines arguments from a vector. All arguments are coerced into a common type, which will the type of the return value and all attributes except names are removed. J'ai pas tout compris là. Qu'est-ce qu'on assigne à x? 1, 2, 3, 4. Names de x, on lui assigne letters 1, 2, 3, 4. X, je ne sais pas pourquoi. C de x. As vector x. Ok, bon. Je sais pas si la commande pour l'interrogation m'aide beaucoup. Type z to view its contents. Notice that there are no commas separating the values in the output. Your dedication is inspiring. You can combine vectors to make a new vector. Create a new vector that contains z, 555, then z again, in that order. Don't assign this vector to a new variable so that we can just see the results immediately. Alors, c'est Z555, Z, si j'ai bien compris. My bad. C'est des virgules pour séparer. Numeric vectors can be used in arithmetic expressions. Type the following to see what happens. Z times 2 plus 100. That's the answer I was looking for. Je me rappelle déjà plus de ce que Z c'était. 1 x 10. 1.10 x 2, ça fait 2,20. Plus 100, ça fait 102. C'est pareil, 9 x 2, ok. Donc c'est un vecteur en fait. Other common arithmetic operators are plus, minus, divided, power. To take the square root, use the square root function. To take the absolute, use the abs function. Okay. Take the square root of z minus 1 and assign it to a new variable called my square root. Okay. My square root. Et qu'est-ce qu'on voulait dedans? Square de z minus 1. Before we view the contents of the my square root variable, what do you think it contains? A single number, i.e. a vector of length 1, a vector of length 0, i.e. an empty vector, or a vector of length 3. Bah, 3, non? Il va y avoir la racine carrée de 0,10, la racine carrée de 9 moins 8, et la racine carrée de 2,14. My square root As you may guess, our first this leaves with a vector of the same length. Yeah, that makes sense. Now create a new variable called myDiv that gets the value of z divided by my square root. Okay, myDiv. Which statement do you think is true? The first element of myDiv is equal to the first element of z divided by the first element of my square root, and so on. myDiv isn't defined. myDiv is a single number. I have no idea. Can I play? Oh, okay. When given two vectors of the same length, R simply perform the specified arithmetic operators elements by elements. If the vectors are of different length, R recycles the shorter vector until it has the same length as the longer vector. Oh, bon savoir. When we did z times 2 plus 100, z was the vector length 3, but technically 2 and 100 are same vector. But technically 2 and 100 are each vectors of length 1. Behind the scenes, are recycling the 2 to make a vector of 2's and the 100 as a vector of 100s. In other words, when you ask R to compute z times 2 plus 100, what it really computes is this z times c 222 plus c 100 100 100. Makes sense? To see another example of how this vector recycling works, try adding c 1 2 3 4 and c 0 10. Don't worry about saving the results in a new variable. 1 2 3 4 plus c 0 10. Ça devrait faire 1 plus 0 1, 2 plus 10 12, 3 plus 0 3, 14, 1 12 3 14. Yeah. It then ouais, okay. I'll still apply the recycling now. Through one intellectually something fishy might be going on. Okay. Like this. La taille de l'objet est plus long n'est pas multiple de la taille de l'objet plus court. Tiens, c'est marrant, c'est en français. Perseverance, that's the answer. Before concluding this lesson, I'd like to show a couple of time-saving tricks. That's good. Earlier in the lesson, you computed z times 2 plus 100. Let's pretend that you made a mistake and that you meant to add 1000 instead of 100. You could either retype the expression or, in manual programming, the up arrow will cycle through previous code. Ouais, bon, ça j'ai fait juste avant. Try hitting the up arrow on your keyboard until you get this command. Then change 100 to 1000 and hit enter. If the up arrow doesn't work for you, just type the corrected command. Et là. Finally, let's pretend you'd like to view the content of a variable that you created earlier, but you can't seem to remember it if you name it myDiv or myDiv. You could try both. You could try both and see what works, or you can type the first two letters of variable name, then hit the tab key. Most programming environments will provide a list of variables that you've created that begins with my. This is called autocompletion and can be quite handy when you have many variables in your workspace. Give it a try. Would you like to receive credit for completing this course on Coursera.org? I have no idea what this means. Let's say no. You're doing so well. We'll reach the end of this lesson. Returning to the main menu. Please choose a course or type 0 to exit Swirl. Faire nouveau. Ça m'a amené sur GitHub. C'est parti. Workspace and Files. Ah, je sais pas si je devrais faire celle-là en stream. Je vais pas montrer mes documents. Je vais me faire hack. In this lesson, you'll learn how to examine your local workspace in R and begin to explore the relationship between your workspace and the file system of your machine. Because different operating systems have different conventions with regards to things like file path, the outputs of these commands may vary across machines. However, it's important to note that R provides a common API for interacting with files. That way, your code will work across different kinds of computers. Let's jump right in so you can get a feel for how this special function works. Determine with which directory your R session is using as its current working directory using get working directory. List all the objects in your local workspace using ls. Ok, c'est bon. Bon, là j'ai pas mis les parenthèses, donc il m'a mis une erreur, mais je l'ai refait après. Donc voilà, donc il y a mydiv, mysquirt, xyz. Some R commands are the same other equivalent command on Linux or Mac. Both Linux and Mac operating system are based on an operating system called Unix. It's always a good idea to learn more about Unix. Assign 9 to x using 9 flash x. X flash 9. Now take a look at the object that generates spec using ls. J'ai pas compris. C'est toujours le même x, mais juste changé de nombre. List all the files in your working directory using list.files or dir. Ça me stresse un peu cette histoire. Ah, c'est bien ce que je pensais. As we go through this lesson, you should be examining the help page for each new function. Check the help page for list files with the command list files. One of the most helpful parts of the help file is also section read that section for list.files. Some of these functions may be used in later portions of this lesson. List.files, c'est pareil que dire. Okay. Using the args function or function name, also a handy way to see what arguments a function can take. Use the arg function to determine the arguments to list files. What is going on? On va mettre ça. Je finis celle-là et puis après on va repartir sur du TFT. Assign the value of the current working directory to a variable called olddir. Like this? We will use olddir at the end of this lesson to move back to the place that we started. A lot of query functions like getWorkingDirectory have the useful property that they return the answer to the questions as a result of the function. Use dir create to create a directory in the current working directory called testdir. Okay. Le point n'est pas passé. Je vois ce qu'il va me faire faire. Okay. Testdir flèche dir create. Args. Oh, bah j'étais bon. What? Bizarre cette histoire de plus. Take only pictures, leave only footprints. Set your working directory to testdir with the set working directory command. Alors, set working directory to testdir. Ok, bon, je commence à choper. Il est moins bien fait ce cours là. In general, you will want your working directory to be simply sensible, perhaps created with the specific project that you're working on. In fact, organizing your work in R packages using RStudio is an excellent option. Check out RStudio. Ok, on est déjà dans RStudio. Create a file in your working directory called mytest.r using the file.create function. File create. Comment il doit s'appeler? mytest. This should be the only file in the newly created directory. Let's check it as listing all the files in your current directory. C'était dire ça. Ou list files. File exist. stick around myTest.r. True. These other functions are accessible for interactive use, but if you are running a program that loops through a series of files and does some processing on each one, you will want to check to see that each exists before you try to process it. Access information about the file myTest.r using file info. Size 0 is dir false, mode my time, c time. Okay. You can use the dollar operator to grab specific items. Change the name of the file by using file.rename. File.rename from myTest.r pourquoi il me dit from? Oh, il y a le from et le to, ok. Donc, file, rename, myTest.r, myTest2.r. Okay. Your operating system will provide simpler tools for this sort of tasks, but having the ability to manipulate files programmatically is useful. You might now try to delete myTest.r using file.remove, but that won't work since myTest.r no longer exists. You already have renamed it. Make a copy of myTest.r called myTest3r, copying the file.copy. From to. Okay. File.copy myTest2 into myTest3. You now have two files in the current directory. That may not seem very interesting, but what if you're working with thousands, millions of individual files? In that case, being able to programmatically act on many files would be absolutely necessary. Don't forget that you can temporarily leave the next lesson by tapping play and then returning by tapping next. Yeah, remember? Provide the relative path to the file myTest3 by using file.path. File path myTest3. You can use file path to construct file and directory paths that are independent of the operating system your R code is running on. Pass folder 1 and folder 2 as argument to file path to make platform independent path names. Pass folder 1 and folder 2 as arguments to file path to make platform independent path name. File path folder 1 folder 2 take take a look at the documentation for dir create by entering dir create. That is the recursive argument. In order to create nested directories, recursive must be set to true. Effectivement. Effectivement. Create a directory in the current working directory called testdir2 and a subdirectory for it called testdir3, all in one command by using dir create and file path. Alors, dir. Excuse me. Dir create. Donc il nous faut un file path. File path. Donc folder 1. Tu l'as ou pas? Folder 1. Folder 2. True et true. Qu'est-ce que tu penses de ça? C'est pas ce que j'ai fait? Ah, recursive égale true, il faut écrire. Excuse-moi. Hop. C'est marrant ça que les guillemets des fois c'est les doubles, des fois c'est les simples. Alors là j'ai exactement ce qu'ils m'ont demandé, je ne sais pas ce qui se passe. Oh, existe déjà. Bah, elle existe, folder 1, folder 2. Bon, je ne sais pas. Ah, mais on veut 2 et 3. C'est juste, j'ai mal lu la question. Non, c'est ma faute. J'ai pas lu la question. puis c'est test dire, c'est pas folder. Ah, je commence à être fatigué. Go back to your original working directory by using set working directory. Set working directory, c'était old dir. C'était old.dir? Non. Si. Ok. Bon bah c'était bien. On va s'arrêter là pour aujourd'hui.